In the previous video, we learned what an AI model is. A system that learns patterns from data and makes predictions. But that raises a very important question. How does the model actually learn those patterns? And once it learns them, how does it use that knowledge to make predictions? In artificial intelligence, these two stages are called training and inference. Hello everyone, welcome back to the AI series, where we learn what's really happening under the hood of AI. In this video, we clearly understand what training is, what inference is, and why every AI system goes through these two stages. By the end of this video, you will understand how AI model actually learn and how they are used in real-world systems. Every AI model goes through two major stages. First, the model learns from data. Then, the model uses what it learned to make predictions. These two stages are called training and inference. Training is the learning phase, inference is the prediction phase. Almost every AI system you use today works exactly like this. For example, image recognition systems, recommendation systems, voice assistants, and modern chatbots like ChatGPT. All of these systems were trained first, then they are used through inference. Training is the process where a model learns patterns from data. During training, the model is given a dataset containing many examples. For example, imagine we want to build a system that can recognize cats and dogs in an images. We collect thousands of images. Each image is labeled cat or dog. The model studies these examples and tries to predict the correct label. At the beginning, its predictions are usually wrong. But after each prediction, the system measures how wrong the prediction was. Then, the model adjusts its internal parameters to improve. This process repeats again and again across the dataset. Over time, the model becomes better at identifying patterns that differentiate dogs from cats. That entire learning process is called training. Once the training process is complete, the model has learned patterns from data. Now we can use the model. This stage is called inference. Inference simply means using the trained model to make predictions on new data. For example, a user uploads a new image. The model analyzes the image and predicts cat or dog. The model is no longer learning. It is simply applying the knowledge it learned during training. That prediction step is inference. Let's look at the full workflow of an AI system. Step 1. Collect data. For example, thousands of labeled images. Step 2. Train the model. The model studies the data and learns patterns. Step 3. Save the trained model. Step 4. Use the model to make predictions on new inputs. So the complete pipeline looks like this: data, training, trained model, inference, prediction. Almost every modern AI systems follows this pipeline. Training and inference also happens in very different environments. Training usually happens on powerful machines with large datasets. It can take hours, days, or even weeks. Inference is designed to be fast. It happens inside applications that people use every day. For example, when a streaming service recommends a movies, when your phone recognizes your voice, when a chatbot generates a response. All of these systems are performing inference in real time using models that were trained earlier. Here's the simplest way to understand this concept. Training is when the model learns from data. Inference is when the model uses that learning to make predictions. Think of it like studying for an exam. When you study and practice problems, you are learning. That's training. When you take the exam and answer questions using what you learned, that's inference. AI models work in the same way. Now, you understood one of the most important ideas in artificial intelligence. Training is how models learn from data. Inference is how models use that knowledge to make predictions. Every modern AI system you interact with today works this way. But another important question appears. What happens if a model learns too much from the training data? Or what happens if it does not learn enough? In the next video, we will explore two critical concepts in machine learning: overfitting versus underfitting. That's it for today. Thanks for watching. See you in the next video.